Hello everyone. This is another lecture of structural geology from Engineering Geology in Remote Sensing subject CE405. In this lecture we will discuss about faults, next important geological structure found in rocks. This lecture will cover following topics. What are faults? Different terminologies used in faults to describe the faults. Classification of faults and causes of faulting. Now what are faults? जैसा कि हमने प्रीवियस लेक्चर में पढ़ा था कि जब रॉक्स पर कोई स्ट्रेस अप्लाइड होती है तो वो अपने आप को एडजस्ट करने के लिए या तो बैंड हो जाती है या फिर उसमें कुछ फ्रैक्चर्स डेवलप हो जाते हैं. अगर रॉक डक्टाइल नेचर की है और डीपली सिचुएटेड है विद इन द अर्थ क्रस्ट, तो जब भी कोई स्ट्रेस अप्लाई होती है रॉक्स पे, मेनली कंप्रेशनल स्ट्रेस, तो रॉक्स बैंड हो जाती है और उसमें फोल्ड्स डेवलप हो जाते हैं. बट अगर रॉक्स ब्रिटल नेचर की है और अपर डेप्थ में अर्थ सरफेस की, तो जब कोई स्ट्रेस अप्लाई होती है, मे बी शेयरिंग, टेंशनल और कंप्रेशनल स्ट्रेस, तो उसमें कुछ फ्रैक्चर्स डेवलप हो जाते हैं जिसकी वजह से रॉक क्या होती है, ब्रेक हो जाती है और डिवाइड होती है डिफरेंट ब्लॉक्स में. दिस फ्रैक्चर्स along which there has been relative displacement of the blocks of rocks are called faults. So faults are defined as it is a planar fracture or discontinuity in a volume of rocks across which there is a relative displacement as a result of rock mass movement. So fractures will be considered as a fault only when there is a clear movement of the blocks created on either side of fracture. If there is no movement, then they are simply fractures or cracks or joints. They are not considered as faults. This photograph shows faults developed in different rocks. This is a fault and arrow indicate movement of blocks on either side of fault. This movement is in opposite direction. The entire process of development of fractures and displacement of blocks of rocks against each other is termed as faulting. This figure in the slide shows development of faults. Figure A shows sequence of 3 layered rocks जिस पर different stress apply हो रही है, compressional as well as tensional. As a result of this stress, fracture F1 gets developed in the rock, which divide the rocks into two parts, A1 and A2. And under the same stress, this two blocks, A1 and A2, move. A2 move downslope with respect to A1. This fracture F1, along which there is a relative displacement of two blocks A1 and A2, is called fault. इस फिगर में हम कुछ माइनर फ्रैक्चर्स और देख रहे हैं, SF1 से डिनोट किए हुए हैं, but they are not faults because there is no relative movement along them. They are simply fractures. Different terminologies adopted in describing faults. First is fault plane. Fault plane is a planar surface along which relative displacement of blocks takes place during the process of faulting. Means fault plane और planar surface होती है जिसके along blocks displace होते हैं या move करते हैं. जैसा कि हम इस डायग्राम में देख सकते हैं, यह अनफॉल्टेड ब्लॉक है. ड्यू टू फॉल्टिंग दोनों ब्लॉक जो हैं वो सेपरेट हो गए हैं और डिस्प्लेस हुए हैं अलोंग प्लेन. दिस प्लेन जिसके अलोंग डिस्प्लेसमेंट हो रहा है ब्लॉक्स का, उसको हम कहते हैं फॉल्ट प्लेन. नेक्स्ट टर्म इज वॉल्स. टू टाइप्स ऑफ वॉल्स आर देयर, हैंगिंग वॉल एंड फुट वॉल. हैंगिंग वॉल जो है वो lies on the upper surface of fault plane. Means this is a faulted block which lies on the upper surface of fault plane, while footwall is a faulted block which lies on the under surface of fault plane. This is a fault जो upper side पे जो block है fault plane की, वो कहलाता है hanging wall. This hanging wall moves with respect to footwall. Footwall जो है वो as such अपनी जगह पे रहता है, but hanging wall moves. तो जो wall move कर रही है वो कहलाती है hanging wall और जो अपनी जगह पर है वो कहलाएगा फुटवॉल. Slip and separation. Slip may be defined as the relative motion of the rock blocks along a fault plane. फॉल्ट जो है वो रॉक को डिवाइड करता है टू ब्लॉक्स में, और उन दोनों के बीच में जो टोटल डिस्प्लेसमेंट होता है ड्यू टू फॉल्टिंग वो स्लिप कहलाता है. स्लिप में बी ऑफ थ्री टाइप्स: स्ट्राइक स्लिप, डिप स्लिप एंड ऑब्लिक स्लिप. दिस इज स्ट्राइक स्लिप इन विच टू ब्लॉक्स डिस्प्लेस्ड इन डायरेक्शन ऑफ स्ट्राइक. डायरेक्शन ऑफ स्ट्राइक ऑफ फॉल्ट इज north east southwest as shown in this diagram. This is a block of rock. This FP is the fault plane which divides the rocks into two blocks A and B. Strike of the fault plane is north east southwest and dip is perpendicular to the strike. So this figure shows the strike slip where the displacement of block B with respect to A is in strike direction. This is dip slip where the displacement of block B with respect to A is in dip direction. Oblique slip में जो slip है वो diagonally होता है to both strike and slip dip direction. This is the direction of strike and this is dip direction. Here displacement or slip takes place diagonally to the dip and strike direction. So it is known as oblique slip. Separation. It is the distance between two parts of the faulted bed or layer of rocks with which were formerly in contact with each other as measured in any given direction. इस फिगर में हम देख सकते हैं ये दो बेड्स हैं या लेयर्स हैं रॉक्स की जो फॉर्मली एक दूसरे से अटैच थी, बट ड्यू टू फॉल्टिंग ये सेपरेट हो गई. सेपरेशन जो होता है वो बोथ वर्टिकली एज वेल एज हॉरिजॉन्टली होता है. सो टू टर्म्स हम यूज करते हैं सेपरेशन को डिफाइन करने के लिए: हीव एंड थ्रो. Heave is the horizontal displacement between hanging wall and foot wall. This is known as heave, horizontal displacement between hanging wall and foot wall, while throw is the vertical displacement between hanging wall and foot wall. Dip and head. The dip of the fault is its inclination with the horizontal, or in other words we can say that it is the angle between heave and fault plane. This D. Angle D is the dip which is angle between heave and fault plane, and this angle is known as head, which is the angle between vertical component or throw and fault plane. It is complementary to dip angle. There are some factors on the basis of which faults are classified, and these are on the basis of apparent movement of disrupted blocks, attitude of fault plane and its relationship with attitude of beds, nature of net slip and mode of occurrence. First classification is on the basis of apparent movement of disrupted blocks. On this basis, faults are classified into normal faults. This fault is also known as gravity fault. In normal fault, hanging wall moves down with respect to foot wall, as seen in this diagram. This is hanging wall. It moves down with respect to foot wall. Fault plane are generally inclined and have high angle dip. This plane is fault plane and it is inclined. These faults are mainly produced when tensional forces is quite large. Some features are caused by normal faulting, such as horst and graben. When two normal faults are on either side of central wedge-shaped block, this V-shaped portion, this portion is known as wedge-shaped block. If it appears high with respect to other blocks, then it is known as horst. This portion is horst, which appears high with respect to these two side blocks. While when two normal faults are on either side of central block, this portion, which appears downward with respect to side blocks, then this portion is known as graben. Next fault is reverse fault. Reverse fault are the faults in which hanging wall moves up with respect to foot wall. This is hanging wall and this moves up with respect to foot wall. Fault plane are also inclined between horizontal and 45 degree. These faults are generally produced due to compressional forces. There are two types of reverse fault, thrust fault and overthrust fault. Thrust fault is low angle reverse fault, where fault dip is less than 45 degree, and these faults are generated when compressional force is added with shear force. This is the diagram of thrust fault, and it is also reverse fault because here hanging wall moves up with respect to the foot wall. Overthrust faults are also low angle reverse fault, where fault dip is less than 10 degree, and they are also generated when compressional force is added with shear force. Next fault is the strike slip fault. It is a fault in which faulted block moves against each other in an essentially horizontal direction. Strike slip fault are further distinguished into left-handed or sinistral fault and right-handed or dextral fault, depending on direction of movement of block with respect to an observer. It is left-handed block fault when where left block moves towards an observer. If observer is standing here, then this block is known as left block. In a left-handed fault, left block moves towards the observer, while in right-handed block, if observer is standing here, then the right block moves towards the observer. Then such type of fault is known as right-handed fault. Next classification is on the basis of attitude of fault. The mutual relationship of attitude means dip and strike of fault and of the disrupted rock, has also been used in some cases for classifying faults. Faults are classified into three types on this basis: strike fault, dip fault and oblique fault. What are strike fault? Strike faults are the faults in which strike of fault and that of disrupted bed of rock is essentially parallel, as shown in this figure A. This is the strike of bed and this is the strike of fault plane. Both are parallel, so this is known as strike fault. In dip fault, fault plane is parallel to the direction of dip of involved bed of rock. This is fault plane, and this fault plane is parallel to the dip of the bed. This is the strike of bed and dip is perpendicular to the strike, so this fault plane is parallel to the dip of the bed, disrupted bed. Oblique faults are the faults in which fault plane is neither parallel to the dip and strike of involved bed, but rather it is oblique to it. Means it makes oblique angle with the strike of the bed. This is the fault strike and this is the strike of bed. Fault strike makes oblique angle with the strike of the rock. Third classification is on the basis of nature of net slip. On this basis, faults are classified into strike slip fault and dip slip fault. Strike slip faults are the faults in which faulted block moves against each other in horizontal direction along strike. This is the strike of the fault. So here the block moves horizontally along the strike direction. And dip slip faults are the faults in which net slip takes place parallel to the dip of the fault. This is strike of fault and this is the dip, 90 degree to the strike. And here the block displaced parallel to the dip of the fault. So this is known as dip slip fault. Oblique slip faults in which net slip is diagonal to both strike and dip. This is the strike of the fault and this is the dip. Here net slip is diagonal to the strike and dip of the fault. So this is known as oblique slip fault. Last classification is on the basis of mode of occurrence. On this basis, faults are classified into parallel faults. Parallel faults are the group of faults occurring in close proximity having same strike and dip. As shown in this figure, these are group of faults. Strike and dip of fault is same. When this group makes a step-like structure, then it is known as step fault. As seen in this diagram, it makes step-like structure. So it is also known as step fault. Echelon faults are the faults which are approximately parallel to one another but occur in a short unconnected segments, and these faults are sometimes overlapping. These are also small sized faults, but here a second fault appears on the surface at a distance before the first fault end. This is first fault. Before it ends, second fault generated on the surface. Before the second fault ends, third fault generated. So these are sometimes gets overlapped. Peripheral faults, when any given region, the majority of faults are concentrated along the margin. तो faults क्या रहते हैं? Concentrated रहते हैं along the margin of the area. Radial faults are also a group of faults that appears emerging from a common central region. As in this diagram, this is a group of faults which appears from a common central region, so known as radial fault. Causes of faulting. Faults are generally caused under the influence of stress, as already mentioned in the presentation, acting upon the rocks of the crust of earth from within. Any rock on or below the crust may withstand all the operating stresses up to a limit, which depend upon its cohesive strength and internal friction. But when that limit is crossed by the operating stresses, the rock gets fractured along certain directions. Immediately after the development of these fractures, the block created along the fractures suffer sudden or gradual displacement, thus giving rise to different types of faults. So this is all about faults. In next lecture, we will discuss about unconformities. Thank you very much.